Alright guys, let's try another question. I've never seen this one before. Increasing triplet subsequence. Given an integer array nums, return true if there exists a triple of indices ijk. So this is a tuple such that I is smaller than j, the indices, yep, j is smaller than k, and nums, the actual numbers are as well. So they need to return false. We're just going to return a Boolean flag here. Okay, so right off the bat, yeah, right off the bat, this is going to be, we're only going to be looking in one direction. We'll only be getting bigger, bigger, and bigger. Well, the indices will only start increasing. So for I in nums, well, I feel like it would be better if we do for I num and enumerate nums. Do, just so I can know which number it is. For enumerate, actually, no, let's do for I in range length of nums, but then we're going to subtract 2 because we do not, because we'll be looking two elements ahead at any given time. Yeah. So let's write I. So num I is going to equal to nums I. Num j is going to equal to nums I plus 1. Num ijk is going to equal to I plus 2. And this will always be inside. So we knew, so just from this, looking at this, we know that ijk, this will always be true. Now the next thing we need to check is if these numbers are strictly greater than each other. So if num k is strictly greater than num j, and num j is strictly greater than num I, we'll be returning true. Else return false. Okay. Seems like this will work. Let's see. All right, let's submit it. Let's see. So we failed here. Let's see what the problem is. So it's expected true, but we got false. So where would have it been true for? 3, 4, 5 is valid. What? Expected true? What are we expecting to be true in this case? What? Any triplet. Oh, wait a second. It's not consecutive. It doesn't have to be consecutive. So for our case, it could be 10, 12, 13. Okay. So yeah. Okay, that's fine. If that's the case, we can still do something similar. Whoops. So very similar to the last one, low, high. Ooh, but there's going to be O of n time complexity. That's sort of crazy. Well, yeah, that's sort of crazy. I think this is the brute force solution where I'm going to, for this, I'm going to go and see if there's something smaller, and if there is, oh wait, no, it's not. Oh, it's literally not. Wait, is it? Wait, let's see. For I and j. So nums I, so that's the number here. And then for j in range 1, 2, length of nums minus 1. If nums j is smaller than nums I, then this is like, no, this can't be right. K is greater than. This must have like terrible complexity. Might get a time limit exceed. Yeah. It goes to 0 and then 2. And it checks. There's nothing. Okay. It's not supposed to be 1, it's supposed to be I. So this will run, but I know the time complexity on this is like terrible. um, how can we do it in O of n time complexity in one pass? Yeah, okay. So it's 1, and then 2. So we're at 1, and then we check 2. It's true. If it's strictly greater, then we go forward. Yeah, okay, that's right. Okay, so 20, and then we check 100. So that's 10, 12, wait, 20, and then 100. That makes sense. Damn, this is sort of crazy. 20, 100, 10, 12, 5, 13. So 20, we have 20. So this is true because we have 10, 12, 13. Yeah. Is it like backtracking? But it's O of n. That's O of n. Like it's a linear, just one pass. So in one pass, there's no for loop in a for loop. Well, I guess it could be a for loop and then another for loop. So for, okay, so let's say 20. No, what? What? Let's add ChatGPT here. Help for this, please. No answer. Just help. Is it binary search? We could do binary search? No, it's not binary search. Can I keep track of the smallest first number seen so far? For each position, can I know the smallest? Start with a very large. Huh. Okay. First, then I have a second. Okay. Wait, this is like finding the second. Oh. Num is bigger than first. smaller than second. Second equals. This is sort of like, damn, this is sort of like finding the second largest element. Wow, okay. So this is sort of like finding the second largest element in a string array. That's crazy. This actually makes sense though. So we keep track of the smallest number that we've seen so far. And then we keep track of the second smallest element that we've seen so far. And if we find a third element that is bigger than the second one, where the second one must be bigger than the first one, then that means this exists. Wow, okay. So the hint here was really the Boolean flag. We don't have to output the exact triplet. We just have to return true or false. Damn. Okay, that was a good one. I like this.